Look at the board. Today we are concentrating on solution of homogeneous partial differential equation involving derivative with respect to one independent variable only. And by observing this example, just look at what is the definition of homogeneous partial differential equation. Each term, look at z. Z is a what? Dependent variable, and here you have derivative of dependent variable. Each term is a dependent variable or derivative of a dependent variable. We call it as a homogeneous partial differential equation. Otherwise it is a non-homogeneous, and we have already discussed non-homogeneous differential equation solution in previous class. So now, and look at here, you first identify z is the what? Z is the dependent variable, and here you find only x is the independent variable. But in case of a partial differential equation, there must be at least two independent variable, but here another independent variable you cannot see in this example, but it will be present. Like you people already know, while eating only hands will work, right? It is not a matter that you don't have legs. You have legs, but legs are constant in that case. So similar fashion, here y is there, but y is absent. So that's what they have mentioned, that it respect to only one independent variable only. So what we need to do is, whenever you have a dou square z by dou x square plus z equal to 0, with respect to one independent variable become, since it is a PDE, right? The PDE becomes ODE. ಯಾವಾಗ ಒಂದು ಇಂಡಿಪೆಂಡೆಂಟ್ ವೇರಿಯಬಲ್ ಇದ್ದಾಗ partial differential equation becomes ordinary differential equation. This will become d square z divided by dx square plus z equal to 0. We know already what is the standard form in the previous example, right? What is standard form? We are going to replace, substitute d square z by or d square by dx square is equal to capital D square, right? We have substituted in the last example. So then it will become capital D square z plus z is equal to 0. This will become d square plus 1 into z equal to 0. I told you to take z common in the right side. Now this is the standard form. Function of d into dependent variable is equal to 0. What is the auxiliary equation here? What is the auxiliary equation? M square plus 1 equal to 0. Let us solve this example. It's a quadratic equation, right? So this will become m square equal to minus 1, m equal to plus or minus square root of minus 1, m equal to plus or minus I. So roots are complex. When roots are complex, what is the solution? Yc is equal to e raised to px, real part, into c1 cos qx plus c2 sin qx. So therefore the solution is, what is solution? Our complementary function is, here we have to write dependent variable is equal to, what is dependent variable here? Z. Z is equal to c1, or first you can write here the real part is absent. Real part is absent in the sense, just look at, you have 0 plus or minus I, means this is P plus IQ, means what is the value of P and Q? P value is 1 and Q value is 1. So therefore you can write, this is e raised to P, 1, P value is what? With respect to this, P value is 0, 0 into x into c1 cos, what is the value of q? Q is 1, qx, 1x or just x plus c2 sin x. Take p is equal to 0 and q is equal to 1, that's all. P is equal to 0 means e raised to 0 x. c1 cos 1x plus c2 sin 1x. So e raised to 0 is what? 1 c1 cos x plus c2 sin x. So when, and look at, we are solving a partial differential equation. Whenever solving a partial differential equation, as you know already, while solving a non-homogeneous PDE, when you integrate with respect to x, we are going to add the constant of integration as a what? Function of y, isn't it? Similarly, since it is second order and it is with respect to x, dou square z by dou x square means to get the value of z we need to integrate twice. So for that purpose, here we are going to add the constant c1 and c2 as function of y, f of y into cos x plus this is g of y into sin x. Hope you understand this. We are going to replace the constant by function of y, because since it is with respect to x, we have to integrate this with respect to x twice. Once with respect to x, we will add one f of y. Another time integration, you will get another function of f of y, means you will get two function of f of y as well as g of y. This is the solution. So once you will get the solution, you need to use these initial conditions. What are these initial conditions? Substitute condition number 1. What is the condition number 1? Substitute z is equal to e raised to y when x is equal to 0. It is when x equal to 0, these will happen. So that's what I have taken first. Z is equal to e raised to y when x equal to 0. Substitute z is equal to e raised to y when x equal to 0. Substitute ಮಾಡಿ right side ಅಲ್ಲಿ f of y, this is cos 0, right? G of y into sin 0. Sin 0 is what? 0. Cos 0 is 1. You will get only f of y. F of y is e raised to y. Now, to use dou z by dou x equal to 1, you need to differentiate this with respect to x. You write, differentiate this equation number 1 with respect to x. ಯಾಕೆ ಅಂದರೆ ನಮಗೆ ಡೋ ಜೆಡ್ ಬೈ ಡೋ ಎಕ್ಸ್ ಯೂಸ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ನಾವೇನು ಮಾಡಬೇಕಿಲ್ಲಿ, ಇದನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, ಝಡ್ ಈ ಬಿಕಮ್ಸ್ ಡೋ ಝಡ್ ಬೈ ಡೋ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು with respect to x, function of y is constant, differentiation of cos x is minus sin x, here g of y is constant, sin x is cos x. Call it as equation number 2. Now you can use the second condition, substitute condition number 2. What is the condition number 2? Dou z by dou x is equal to 1 when x equal to 0. Dou z by dou x is equal to 1 here and x equal to 0. X equal to 0 is what? The first value becomes 0. Cos 0 is 1. 1 into g of y is g of y. If you don't know means we can write here f of y into, this is minus sin 0. This is g of y into cos 0. So therefore 1 is equal to, this is 0 plus g of y, or g of y is equal to 1. So we need to substitute g of y and f of y in equation number 1 finally. Therefore what is the solution? The solution becomes z is equal to, what is f of y value? F of y value is e raised to y into cos x plus what is g of y value? 1 into sin x. So this is the solution of homogeneous PDE with respect to one independent variable. Thank you. Okay.